Our next lesson is called Solving Inequalities. An inequality is similar to an equation, except that the left side is not necessarily equal to the right side. Use the exact same rules for solving equations. Okay, so you're going to follow those same exact steps. It's just that your answer means something a little bit different. One big thing we do have to remember, however, though, so let's put a star there, is it says, however, when multiplying or dividing by a negative, you must flip the inequality symbol. So let's take a look at a chart going over the different meanings, examples, and graphs that we have for inequalities. So the first one is less than. The less than symbol is going to look something like this. X is less than 2. If we're going to graph that, we would not want to be including 2. 2 is not part of the answer. X is strictly less than that. So we would make an open circle on 2, and then we would shade all the places where X would be less than 2. That would be to the left here. And if you have your inequality written with the variable first, the inequality symbol is actually pointing in the direction that you should shade. Our next one, less than or equal to, might look something like this. X is less than or equal to 2. Okay, so it's got the line underneath the inequality symbol to show the or equal to part. So we still have a circle on 2 like we did in the first example, but the difference here is that with less than or equal to, the 2 is included in the answer. It counts. So we have to show that by actually shading in the 2 and then still shading to the left since it's less than or equal to. Then we have greater than, so we'll write X is greater than 2. 2 is still the answer, so we're going to go to 2. There's no line underneath. There's no or equal to, so it's going to be an open circle. Now we have the numbers that are greater than 2. Those would be numbers to the right. So you can see how that's in contrast to X is less than 2 in our first example. The arrow is being shaded in the opposite direction. If I have greater than or equal to, then we have X is greater than or equal to 2. We're going to go to 2 and put that circle, but because it's or equal to, the 2 is going to count. So I will fill it in, and we want to shade to the right, just as we did in the example before, because it's still greater than or equal to. And then lastly, one that you may not think about as much is not equal to. That would look like this. X is not equal to 2. So if you think about that, 2 is the only number it cannot be. So I'm still going to put a circle on 2, but I'm going to leave it open because 2 is what it cannot be. It can be everything else. So this is a special situation where you have to shade to the right because it can be numbers bigger than 2, and you have to shade to the left because it can be numbers smaller than 2. It just cannot be the number 2. So now we're going to go through and solve some different inequalities and practice these things we just talked about. If we have to multiply or divide by a negative, make sure we flip the symbol. And then we have to make sure we are carefully graphing, think about open and closed circles and where we should be shading. So the first one, negative 3x plus 4 is greater than 5. We are going to follow the same exact process for solving equations. We still want to start by looking for a distributive property, which we do not have. Combining like terms on each side separately, which again we do not have here. Variables on both sides, which we don't have. And then once we get to that, we should be looking to undo addition or subtraction, which we do have. So we're going to get rid of adding 4 by subtracting 4. You still have to keep to that fact that whenever you do to one thing, you must do to the other. So negative 3x is greater than 1. So then we look to undo any multiplication or division. We have multiplication. Negative 3 and the x are written right next to each other. So the opposite would be to divide. We're still dividing by the coefficient. But now we have just divided by a negative in order to solve this inequality. So let's make a note that this is one we have to switch the symbol for. So these will cancel and I'll get x, but I'm no longer going to write is greater to. than I'm going to write is less than. And my answer here is negative 1/3. Now on the number line, this first one I'm giving you a number line that's already filled in. Sometimes that will happen. So if it's already filled in, you can go right to the part where you are locating negative 1/3. Now negative 1/3 is going to be between 0 and negative 1, 1/3 of the way of the left of 0. So I'm going to draw a line in there and label it as negative 1/3. It is less than, so it's an open circle. And then I'm going to go to the left because that's where the numbers are less than negative 1/3. Let's take a look at the second example. 3x plus 2 is less than or equal to 5 times x minus 4. So running through the steps, just like we do for equations, is there distributive property? Yes. So I'm going to take this 5 and distribute it through, which is multiplication. So we get 3x plus 2 is less than or equal to 5x minus 20. Then I'll look for like terms on the left. I don't have any. Like terms on the right. I don't have any. Then I go to variables on both sides. That I do have. Because it's even in size, you can either get rid of 3x or the 5x. I'm going to choose to get rid of the smaller one, which is 3x. Since that's positive, I'm going to subtract. Whatever I do to one side, I must do to the other. So 2 is less than or equal to 2x minus 20. So then I have some addition or subtraction to look for. I have subtraction of 20. So I'm going to add 20 to each side and get 22 is less than or equal to 2x. Then I don't want 2x. I got to undo that multiplication by using division. So I get 11 is less than or equal to x. No need to switch the inequality at any point in solving because it only gets switched if we multiply or divide by a negative number in order to solve. And we did not do anything like that. Now, if you do not want to leave your inequality written this way, you can switch it. Just be very careful. Put the x first and the 11 second, but make sure the inequality symbol is still open towards the larger thing. So x is on the side where the inequality is open, like the mouth is open towards that, which means it's greater. So make sure when you switch the order, you also account for that with the symbol. Now, this number line does not have any numbers on it. So if you're required to make a number line yourself, you just have to make sure whatever you need is kind of in the middle. So there's 11. And you can either give me one number to the right and one number to the left, or you can even do 2. But that's all we need. It does not need to be an elaborate drawn number line. Then we will take our answer of 11. It was x is greater than or equal to 11. So this one's easier for graphing purposes. Because it's greater than or equal to, I'm going to put that circle around 11 and fill it in because x is greater than or equal to 11 means 11 counts as well. And then where the numbers are greater is to the right. If you're ever having trouble deciding where to shade, you can pick a number to the right and plug it in and check the inequality. If it works, shade that way. If it doesn't, shade the other way. Now let's move on to a couple more examples. On the next page, we have 17 is less than 2 minus 3x plus 4. So the first thing I should be doing is the distributive property. Please take the sign with it. That's a negative 3 that you should be distributing through the set of parentheses. So this is 17 is less than 2. Negative 3 times x is negative 3x. Negative 3 times 4 is negative 12. Now notice what I did not do. I did not do 2 take away 3 before I did the distributive property. And that's why I wanted to include this example. You have to make sure you're following your order of operations. Multiplication comes before any addition or subtraction. So the negative 3 gets distributed and the 2 just gets carried down. Now we look for like terms. On the left, I don't have any, but on the right, I can combine 2 and negative 12. So I end up with 17 is less than negative 3x, and then this would be minus 10. I do not have variables on both sides, so I'll go to undoing my subtraction by adding 10. And I get 27 is less than negative 3x. I don't want the x to be negative 3x, so I'm going to divide by the coefficient. And I am dividing by a negative number. Alarm, alarm. Okay? That means we need to switch the symbol. So I'm going to get negative 9, and instead of less than, I'm going to put is greater than x. Now, if we want to rewrite it in the more friendlier version, we'd put x on the left, negative 9 on the right, and the mouth was still open towards the negative 9, so you want to make sure it still is. Okay, so we're looking at x is less than negative 9. So negative 9 is going to go in the center. I'll do a couple larger and a couple smaller, and then I will graph. So because it's x is less than negative 9 is not included, so we show that by an open circle, and now the numbers that are less than negative 9 are to the left. All right, underneath that, we have 2x plus 11 is greater than 4x minus 7 minus 16. So here, we are going to look for distributive first. We don't have it. Then we'll look for like terms. We do have that on the right-hand side. We have a negative 7 and a negative 16 that can be combined. So this will be 2x plus 11 is greater than 4x minus 23. Then variables on both sides. I have a choice. I can get rid of the 2x or the 4x. I'm going to get rid of 2x by subtracting 2x. Since it's positive, I want to do the opposite operation. So these are gone, and I get 11 is greater than 2x minus 23. I'm going to undo my subtraction by adding 23 to both sides. So I get 34 is greater than 2x. Lastly, I don't want 2x, so I'm going to divide by the coefficient, and I end up with 17 is greater than x. No multiplying or dividing by a negative, so there's no need to do anything with the symbol. Again, though, we will rewrite it as x is less than 17. So I will make sure 17 is in the center. Again, a couple above, a couple below. X is less than 17. That means 17 does not count, so that's an open circle. And where the numbers are less is to the left. Okay, now I'd like you to do the think about it question. You're going to solve the inequality below. What does its final strange result tell you? And then underneath that, how would you graph the solution set to this inequality? I'd like you to pause the video at this time and try this question without me. Then when you're ready to go over the answer, you can resume. Okay, at this time you've tried the think about it question. You should have solved the inequality by using the distributive property, getting rid of variables on both sides, and you would have seen that your variables totally disappeared, and you ended up with a statement negative 1.5 is greater than or equal to 3, which is not true. So make sure you have slashed that inequality. So what final strange result happened, and what does it tell you? You ended up with a false statement, so there is no solution. So how would you graph the solution set to this inequality? Well, you wouldn't. Since there's no solution, it's an empty graph. And that concludes our lesson on solving inequalities.